Startup file is the first file to run, and it creates all the foundation level preparation for the microcontroller to run. Startup file is in the hex code. If you have done some hex code in the college, then you will know that we have the mnemonics, and using that we write the code. Syntax are there, and the CPU is Cortex-M4, and it supports the thumb instruction. Then we have defined some global variable. After that, I have defined some sections. So this is a reset handler section. This reset handler is a function. The type is function. Then this is my reset handler function. The first thing what I am doing is stack pointer I am setting as the end of the RAM. So if you remember from our memory map, stack we have kept at the end of the RAM. Some of the symbols like E stack has come from the linker file, or whichever the symbol started with the underscore, it has come from the linker file. When we will see the linker file, then you will see these symbols are defined there. After that, this is the data initialization. All the data part we are copying from the flash and keeping it into the RAM. Since this is a initialized data, so whatever the initialized value is there, that also we are copying here. Here I am initializing my registers. Here looping to copy data. I am checking the addresses. It should go till the end data. Then here I am doing my copy of. So after that, what I am doing is I am just initializing the BSS segment. So whichever the uninitialized segment is there, BSS, so that segment we initializes with a 0. That same operation we are doing here. Here I am setting up my registers with the start of BSS, end of BSS. I am jumping to the here, and then I am comparing the R2 with the R4, whether it's ended or not, and then I am going to the field 0, and here I am filling the 0 to the addresses, and then I am updating the address here. Now my reset handler almost come to an end. After that, we are doing the system clock, and after that port clock configuration we have done, and after that we are jumping to the main function. So main was in the application. After that, nothing. I'm just calculating the size of the reset handler. That's it. This is one function, complete function we writes in the startup code. Now you understood what are the basic preparation we are doing before jumping to our application. And after the reset handler, we have few more things. So this is the default handler. This is also a function, and what this function is doing is nothing but just looping in the infinite loop. So why this function we have given is, so in our microcontroller there are lots of exceptions are there. So suppose if you try to access a area which is protected, we should not supposed to access, then in that case controller will throw an exception. Exception is nothing but the internal interrupt. Currently I have mapped all the interrupt to this default handler. So any interrupt will trigger the default handler, and default handler is nothing but while loop. So after the default handler, I have created a interrupt vector table. So any interrupt will get triggered, that will lead to call a function. That function is the ISR, interrupt service routine. So every interrupt has different ISR, and all those ISRs mentioned in the interrupt vector table. So one section is there, interrupt vector table. In the interrupt vector table, currently I have not mentioned all the interrupts, only the important interrupts I have mentioned. The interrupt vector table starts with E stack, and we have the reset handler after that, then the NMI handler, hard fault handler, non-maskable interrupt, memory management handler, bus fault handler, uses fault handler. So all the important handlers I have kept here. Since when the microcontroller starts, first thing it does is it loads the stack pointer with the first element of the vector table, and then we jump to the recent handler. All the fault handlers I have aliased as a weak. So weak is a very important keyword in the C. Currently all the handlers I have mapped to the default handler. Later in the project, if you want, you can define these hard fault handlers somewhere in your code, and then it will be mapped to that function, will not go to the default handler. This was all about the startup file. This is our linker file. So in the linker file, first thing we define is the entry point. So entry point is nothing but the reset handler. So after the microcontroller boots up, it will initialize the stack pointer, and then it will initialize the program counter with address of this function. So that's why reset handler on the entry. After the reset handler, end of stack we have defined here. That is nothing but the origin of SRAM plus length of SRAM. So we are going till the last, and here is the memories. What are the memories currently we are using in our microcontroller? So SRAM we are using, origin is this, length is this, and then flash we are using, start address is this, length of the flash is this. If you want to see the addresses, our SRAM starts with 2, and after that 7 zeros. So this is our SRAM, and it goes all the way till here. So that's the total size of our SRAM. And after that we have the flash memory. So this is our flash memory. As we saw, it is starting from 8, and after that 6 zeros. In total 512 KB it is. So same thing I have written here. After that we have defined the sections. So sections are nothing but what we saw in the C programming memory layout. So we had different sections. We have .text section, we have data, .bss, .stack, all these sections are there. So if you will see at very first, what I have defined is, if you remember C programming memory layout, at the starting of the memory, we keep our vector table. ISR vector, which we define into the startup file, that ISR vector I have given here. This is a section. That section I am keeping into the flash. These are nothing but some linker syntax. After the interrupt vector table, we define the reset handler. So this is our reset handler section from the startup file. This will also go into the flash. So this will come exactly after reset handler. All the section positions you can change also according to your wish. After that, I have kept the default handler. So this will go to the .text.default handler, and this will also go into the flash. And after that, I have defined the .text section. So all the .text and arrow data, those will go into .text section, and this will also go into flash memory. So now after the text section, I have defined the data section. So all the global initialized data, local or global static variable, those will go into this section. So this is the start of data section. This is the end of data section. In the startup file, we are initializing every variable with its corresponding value. And this SI data section, we are copying from flash to SRAM. So this is the command for that. And after that, at last, we have BSS section. So BSS is uninitialized. So what we are doing in the startup code, uninitialized section, we are making all as 0. This is our BSS. This is the start of the BSS. This is the end of the BSS. And if you will see BSS, directly we are putting into the SRAM. So yeah, this was all about the linker script sequence in which you will write this. In this sequence only, these sections will create into the memory. This is a very small project, but still in this project, 3-4 source files we have, one startup file we have, all those files we need to compile. If you will compile this file using only the command interface, then lots of command you will have to write every time. That will be very difficult. So to overcome this issue, we have the Makefile. In the make system, we create one Makefile, and inside that Makefile, we write all the commands, which are all the commands we want to execute to build this code. During the build process, we just have to give the make all. So it will save us from every time writing the all commands. So this is a small Makefile. Some syntaxes are there. Here in the Makefile also, I have given all the steps in the detail. So first, we have defined the directories, build directory, app directory, etc. And after that, we have defined the compiler prefix, which cross compiler we are using. We are using the ARM non-EABI GCC. And then which CPU we are using, Cortex-M4. If you remember, the same we have defined in our startup file also. These are nothing but the compiler flag. All these detail, what this flag does, these details you can find into the compiler user guide. Compiler flags, we have the CPU, then we have the thumb instruction set. So we have the standard, which is GNU 11. WAL is to suppress all the warning. We have optimization flag. Currently optimization I have kept as 0. And then we have debugging flag. If you will give this flag, it will create the debugging related informations. Then we have the linker flags here, the stdlibs, which linker script we have used. We are generating the map file also. So in the map file, we will get to know which section goes to which addresses. So complete mapping we can see in the map file. So this has been generated by the linker. So this is make all. So make all, what is the final? Finally, what we need? Finally, we need the binary executable file. That is the .elf file, right? And this file we need under the build directory. So that's why this alt command is there. Now, to make this ELF file, what are all the things are required? The linker takes all the object files and it makes the ELF file. All the object file and the linker script. Linker script we have already given here. What is remaining is object file. So all the object files we are giving here. So all the object file will be created in the build directory. Main object file, BB delay, BB system clock, port, startup file, object file. All these object file will get created in the build directory, and all these will be used by the linker to generate this .elf file. These object files, how we got? What compiler does is it takes the C file, source file main.c, and it converts the C file into object file main.o file. Now in the project, many times we do lots of changes. Okay, whenever you do any change in the make file, or any change in the linker file, then what you need to do is you need to delete all your generated files, like your object file, your ELF file, your map file. All these files you need to delete and then rebuild. So doing no need to do it manually. Here in the make file only we have one clean command. So make clean. So this will clean all the generated files. So this is a simple make file we have. I explain on a high level. If you want to go in depth, you can read these definitions, and you can also refer the GNU GCC Makefile user guide. So this was all about the different files we have in our project. Saw the contents of each file. If you wish to know more in depth, then you can go through each and every file. You can go through the comments, and also you can go through the documents, and you can make your tweakings things, and you can see how it is changing the things.